Hey everyone, and welcome to the Foundry by Forge College. I'm absolutely thrilled to have you here today. So grab your hard hats and, maybe some steel-toed boots, because today we're stepping straight onto the construction site. Our explainer today is building and running Foundry tests. We are finally taking all those theoretical testing blueprints we've been staring at and turning them into real, actual runnable code. Yep, we're pouring the concrete today, folks.
Now, if you were hanging out with us for our previous lesson on designing data collection for transaction analysis, you already know just how absolutely crucial it is to properly gather and structure your data before you build. Okay, let's dive into this. We're going to apply that exact same methodical mindset to our engineering process today. It boils down to 4 distinct phases. First, we lock in our design strategy. Second, we code our fixtures. Third, we actually run the tests. And fourth, we check our coverage to see exactly where our blind spots are hiding.
So here's our architectural plan for today's explainer. We're going to move from blueprint to execution, then we'll be setting up your fixtures, looking at unit and flow tests, running your test suite, and finally, generating those all-important coverage reports. Let's get to work.
All right, kicking things off with Section 1, from blueprint to execution.
As any good engineer knows, a beautifully drawn blueprint is, completely useless until you actually start pouring the concrete. I really want you to burn this phrase into your memory. Tests only prove value once they run. I mean, having a testing strategy is great and all, but until we transition into our test directory using our compiled Hardhat artifacts and Foundry, it's literally just theory. Right now, we are laying down the foundation to rigorously verify every single line of code.
Moving right along to Section 2, setting up your fixtures.
So this is the very first phase of actual coding, putting up the scaffolding. The absolutely crucial point here is understanding the setup function. I want you to think of setup as your foundational scaffolding. It's a shared fixture function that establishes a completely deterministic, repeatable starting state before any of your tests even run. It basically centralizes all your common setup logic. Imagine you're building a massive apartment complex, right? You wouldn't pour a completely new, unique foundation for every single room. That would be, exhausting and totally chaotic. Setup ensures your contracts are deployed identically every single time a test fires.
And here is exactly what that scaffolding looks like in practice. You're going to want to create a base file, typically something like testfixtures.sol inside your test folder. Inside there, you'll import forge sten/test.sol. That gives you access to all of Foundry's powerful testing utilities. Then, right inside your setup function, you deploy your contract handles. By inheriting this fixture file in your other test contracts, you keep your workspace incredibly clean. Seriously, this kind of modularity drastically reduces code duplication, and that means way less maintenance and far fewer headaches for you down the road.
All right, Section 3, unit and flow tests.
Okay, our scaffolding is up, the site is secure, and now it's time to actually test our materials. And this brilliantly illustrates our 2 main approaches. Over on the left, we've got unit tests. Think of these as your bricks. They focus entirely on pure logic, edge cases, and ideally, they contain just a single assertion. They verify that one specific piece of material is structurally sound. On the right side, we have flow tests, or integration tests. This is your plumbing. Flow tests involve multi-step integrations that mirror realistic real-world usage. You're turning on the faucet in the bathroom just to make absolutely sure the water flows all the way from the main line without leaking into the living room. Both are absolutely vital to your build. To actually verify all these tests, we use something called assert equal. This is essentially the building inspector's tape measure. It's a built-in Foundry utility that verifies if the expected value in your blueprint perfectly matches the actual state of the built wall. Say you expect a user's balance to be 0 after a transaction. Well, assert equal measures it. If it's not exactly 0, boom, it throws a highly readable error letting you know exactly where your math or your logic went sideways.
Next up is Section 4, running your test suite. So, the wiring is done, the plumbing is connected, and now what? It's time to turn on the power. These commands are the literal switches we flip to jumpstart our machinery. First up, Foundry up -- version ensures your tools are installed and completely up to date. Next, forge init -- minimal initializes a clean Foundry environment right in your directory without completely overriding your existing contracts. And finally, the big one, forge test -v. That runs the suite with that little -v adding verbose logging so you can see exactly what's happening under the hood. Oh, and by the way, if you ever find yourself wanting to deeper dive into mastering the terminal and command line interfaces for Web3, we've got some fantastic wider learning programs over at Forge College that can literally turn you into a command line wizard.
Now, let's talk about what happens when things go wrong. The quote we're looking at says, check import paths and uninitialized constructors. It sounds super simple, right? But you would be amazed. This is basically the Web3 equivalent to building this gorgeous house, only to realize you installed the front door so it opens directly into a brick wall. If your tests fail to even compile, I'd say 99% of the time, your import paths are just wrong. Remember, Foundry resolves relative to your project root and the lib folder. But if they compile and then fail instantly, check your constructors. Are you testing a state that hasn't actually been initialized yet? Always check your doors, folks.
Which brings us to Section 5, generating coverage reports. Okay, the lights are on, the water works perfectly, but we're not quite done. It is time for the ultimate building inspector's checklist to ensure absolutely no dark corner was left unchecked. To generate this checklist, we use a command called forge-coverage-report lcoff. This runs your tests and tracks exactly which lines of code were executed and which were totally ignored, outputting it all into an lcoff.info file. Now, raw text files aren't exactly fun to read, so you're going to want to convert that file into an HTML report using tools like GenHTML. That gives you a beautiful, visual, line-by-line breakdown of your smart contracts. Red means untested, green means tested. It's awesome because it lets you visually spot unexercised branches, missing access control guards, and untested functions in a matter of seconds.
Now, what's really interesting here is the number 0. 0 is the magic number. Before you even think about looking at your coverage reports, your test runner needs to show exactly 0 failing assertions. Seriously, do not try to optimize your coverage if your core tests are currently broken. Get everything passing, 0 failures, and then use your coverage report to find out what you missed.
Once you've got that 0 failure coverage report in hand, your next step is to create a punch list. You'll want to keep a list of your top 3 to 5 untested functions or branches. This becomes your punch list for our final architectural review. Actually, in our next lesson on improving coverage, we're going to take this exact list and systematically hunt down those gaps, adding new assertions and edge case tests to make our smart contracts completely bulletproof.
So I want to leave you with this somewhat provocative thought. Are there hidden bugs lurking in your untested constructor branches right now? If you haven't run a coverage report today, the honest answer is, well, you just don't know. The only way to sleep soundly is to build the tests, run them, and verify the coverage. Thank you so much for joining me today on this explainer. If you're ready to master your Web3 engineering skills and dive deeper into advanced testing frameworks, please come visit us at forge.college. We've got an absolutely amazing community and tons of resources waiting for you. Until next time, keep building, keep testing, and I'll catch you on the next one.